Today's lesson objective is 4.9A. Represent data on a frequency table, dot plot, or StemLeaf plot marked with whole numbers and fractions. Let's begin with the frequency table. A frequency table is a table used to organize data that lists categories and the frequency, or number of times, that each category occurs. Some of the characteristics of a frequency table is that it has a title that clarifies the meaning of the data being represented. It should have categorical data that is represented with the labels. It should have data represented, or data represented may be objects. It could be events, numbers, or a range of numbers. We use tally marks to record frequencies, and numbers are used to represent the count of the tally marks in each of the categories. Finally, the count of tally marks represents the frequency of how often a category occurs. So let's look at this example. Martin recorded the number of miles he rode his bike each day for 27 days. Represent the data using a frequency table. Okay, so to start with, you want to make a table with 3 columns. So the first column is going to be whatever your data represents. So in this case, our first column is going to be number of miles. Pound symbol is just abbreviation for the word number. So number of miles on his bike. Okay, we could say number of miles ridden. Just some way to basically define what it is your data represents. Alright, now this middle column is going to represent your tallies. This is where you're going to tally each time a number shows up in your data. And then the last column we're going to call frequency. So this will just be the numerical count of the number of tallies you end up with at the end. Okay, so first off, you're only going to write down each number once in the first column. Okay, so look at what different numbers you have. It's best if you can list the numerical data in order from least to greatest. So we have 5 3/4. The next lowest value, it looks like, is 6. After 6, we have 6 1/4. And it looks like we have 6 1/2. Okay, and that's all the 6s. So we have a 7, and I don't see any mixed numbers with 7, so we go to 8, and we have an 8 3/4. And then our final one here, it looks like, is 10. Alright, so once you've listed each of the numbers that are represented in your data, now we're going to tally each time one shows up. So the first number here is 5 3/4, so I'm going to put a tally right here. And then we mark it out, knowing that we used it. The next one's a 6, so we'll put a tally there. 6 1/2. Then 7. And 6 again, so we put another mark there. And 6 1/4, and then we have another 6 1/4, then another 7. Okay, we continue this pattern until we get to the end. Okay, so I paused the recording so that I could finish making the remaining of the tally marks. So all you see here is I just went through and tally marked each of the data points as we had talked about. Now notice that on the 6 1/4 and the 7, when I hit the 5th tally mark, I used a slash through 4 marks. Okay, so that just makes it easier later when you're trying to go back and count them, especially if we had a lot more data here, so we had a lot more marks to count. Making that slash just makes it easier to count by 5s on those. So finally, our frequency column, we're just going to put what the actual numerical count is for these tallies. So for 5 3/4, we have a 4. For 6, we have 3. For 6 1/4, we have 8. And for 6.5 we have 2, for 7 we have 5, for 8 we have 3, 9 we have 2, and 10 we have 1. So frequency tables are great for identifying your mode of your data. Obviously we can see that this one shows up the most often because it has the highest frequency. So, sorry, ignore that last mark. So that makes 6 1/4 our mode. Okay. So this is all there is to creating a frequency table. Just list each value once and then create a tally for each time the value shows up and then make a numerical count for it. Alright, the next type of graph we'll look at is the dot plot. Dot plots are a graphical representation to organize data that uses dots or x's to show the frequency, again, or number of times that each category or number occurs. Some characteristics of a dot plot. The title clarifies the meaning of the data represented. Categorical data is represented with labels. Now, when categorical data is used, it needs to be orderly and not arbitrary, which meaning orderly meaning that you can put it in a sequential order, so it has like a first, second, third pattern, whereas arbitrary just means it's random. Numerical data is represented with labels and may be whole numbers, fractions, or decimals. Data represented may be objects, events, numbers, or a range of numbers. Categories are represented by a line or number line labeled with categories. Okay, so you're basically going to create a number line, and then each mark on the number line will represent your categories. Counts related to numbers represented by a number line. So it says dots or x's recorded vertically above the line to represent the frequency of each category or number. So basically we're going to place a dot or an x each time one of those appear on the number line in our data. And so dots or x's generally represent just one single count, and dots or x's may represent multiple counts as long as you indicate it with a key. So if your dots or x's on your number line actually represent 2 or 3 data points, you need to make a key to say that so that somebody reading your graph would understand that. Value of the category is determined by the number of dots or x's drawn, and density of dots relates to the frequency of the distribution of the data. So let's take a look at some of these characteristics on the data plot we're about to create. So here it says Martin recorded the number, so same setup. Okay, I'm using the same problem to make our dot plot out of. All right, so we're going to create a number line, all right, that would make sense for this data. So you notice that our number of miles is basically counting in quarters, right? And our lowest data point was 5 3/4. Our highest one was 10. So when we create our number line, it makes sense. We don't need to technically start at 0. We can start at a different value. So for this one, I would probably start my number line at the lowest data point, which is 5 3/4. And then I would make each mark count by a quarter. So here's 6, 6 1/4, 6 1/2, 7 or 6 3/4, 7, 7 1/4, 7 1/2, 7 3/4, and it looks like we're going to run out of room before we reach our goal of 10 here. So hold on, I may need to extend my number line a bit. Alright, let's see here. Okay, so we have 8 3/4, 9, 9 1/4, 9 1/2, 9 3/4, and finally 10. Okay, So now we should make a title for our graph. So our title can be what the data represents. So again, we can call it number of miles on the bike or something of that nature. Just something that makes sense for our data. Okay, and now you're going to place a dot or an X above each time one of the data points shows up. So we're going to do 5 3/4. We simply put an X there. 6, we put an X there. 6 1/2, we place an X there. 7, and you just keep going down your list, okay? And if you have a repeat, you just put it right above the previous one. Okay, and so we're going to keep doing that until we've gone through all our data. Let me pause the recording as I finish out the X's. Okay, so I've completed marking the X's where each of the data points lied. And so once you have a completed dot plot, what's useful with this is, again, you can kind of see where the frequency of your data mostly appears. So again, you see your mode here is at 6 1/4, but you can also notice that the majority of your data points fall between 5 3/4 and 7, with just a few data points falling up here on the higher end. Okay, so it's a great way to see where the cluster of your data mostly lies. All right. So our next graph is the StemLeaf Plot. StemLeaf Plot is a graphical representation used to analyze and compare groups of or clusters of numerical data by separating one place value from another place value of a data set. The larger of the two place values is called the stem, and the smaller of the two place values is the leaf. Okay, so some characteristics of a StemLeaf Plot. Again, you create a title that clarifies what the data represents. Numerical data is represented with labels and may be whole numbers, fractions, or decimals. The place value of the stem and the leaf is dependent upon the values of the data in the set. So for decimals and fractions, usually your whole number is your stem, and the decimal or the fraction part represents your leaf. If it's for sets of data that are close in value, usually the stem is represented by the place value of a number before the last digit, and the leaves are represented by the last digit in the number. The stem represents one or more pieces of data in the set, and the leaf represents one piece of data in the set. So, in other words, your stem could represent multiple pieces of data, but your leaf is one for each single piece of data. Density of leaves relates to the frequency of distribution of the data. All right, so same data. So now we're going to form a StemLeaf plot. So you notice our data is mixed numbers. So as the characteristics describe, for this, you're going to need two columns. One side is your stem. And I should have made a title for this. I didn't leave enough room at the top for the title. But again, the title for this one could be miles ridden on a bike. Okay. Now the first thing you should do for a StemLeaf plot is make a key. The key is what tells us what each stem and leaf represent in the value. So for this one, I'm going to make my key be the whole number and my leaf be the fraction. So this would be the same as the data point 3 1/4. Okay, so my stem is the whole number, my leaf is the fraction. So when I fill these in, again, start by making your stems. So 5 is my lowest whole number, 6 is my next, and I have a 7, an 8, a 9, and I have a 10. And now you're going to fill in your leaves. So your leaves are your fractions. So you got to have one for each one. Now for the 5s, I only have 3/4. So I'm just going to put 3/4 here. But I got to put one for every time one shows up. So that was this one. Then I have a second one down here on the bottom row. Okay, and I have a third one down here on the bottom row. So you got to write one for each time it shows up. You don't just write the one time. And then you go on to your 6s. Now if there's no fraction tied to your 6, then you got to put a 0 there so that somebody would know that you had one that was just 6 with no fraction. Okay, and you want to make sure you have zeros for each one of those that you have. Okay, and then you go in order, so least to greatest here. So we got a 1/4 over here, and another 1/4 just below it. All right, and we just keep going until the chart's filled in. So I'm going to pause it, and I'll finish completing the chart. Okay, so we've completed the stem and leaf plot, and so you can see by doing the stem and leaf plot where the majority of our leaves fall. So the most of our data is falling with a whole number of 6 in a fractional part here. All right, so stem leaf plots give us a quick visual way to see where the majority of our data falls. So most of it falls there. But you can see it almost makes like a what we call